Hello all, welcome to Matlab Simulink for Beginners, Class 4. So far we have created a software component and inside the software component we have created 4 modules and we have interconnected them. And today we are going to see how to write software coding inside those modules. Okay, let's go to Matlab. Okay, let's start doing the coding for first module. Let's go inside the model and remove this default link and keep all your inputs on the left side and output on the right side. Now there are two important things you should know about it, Simulink. So this Simulink is a model-based tool. So in this model-based tool, either you can write the code in a pictorial way, or you can write the manual code like the C language. So there are two options. So it is up to the user to decide which type they want to go with it. So we are going to learn both method. Um, so first we will learn about how to do it in a pictorial way, and then we move to the state flow. That's the writing the code like a C language. Okay, let's start with the pictorial method. As per our design, there are set of criteria it should meet in order to set this passive to active trigger. So the first condition is vehicle should be in a standstill. So for that one, there is no direct input as such. But what we can do is that we can derive whether vehicle is in standstill or not with the help of this vehicle speed. So how we can do that? So we can check whether the vehicle speed is in zero or not. So that's the one of the way to identify whether the vehicle is in standstill or in the moving condition. But in order to make it a robust way, we can use one threshold, like if the vehicle speed is below, for example, zero point 0.5 meter by seconds, then we can say that vehicle is in standstill condition. Okay. Now, if we want to use a threshold, then we should add a constant or tuning parameter. So why we call it a tuning parameter? That means we can change this constant value later. So that's the meaning of tuning parameter. Okay. So how to add a threshold and how to compare against the signal. So first we will create a constant. Okay. For that one, double click on the white space and type a constant. And if you want to keep it as a constant, if you don't want to assign as a tuning parameter, then you can right away assign the value like 0 0.5 meter by second. Uh, you can assign a mean and max range, or you can leave it. Okay. So this is the way to create a constant. But if you want to make it as a tuning parameter, then what you can do is like again double click on the constant. Here you can write a name like the vehicle standstill threshold. Okay, and go to here. You can say create. So this action will create a tuning parameter and select to the location as a data dictionary. And the value is selected as a Simulink parameter because this is a tunable parameter. So you have to select the value as a parameter, then say create. And here it will ask the default value. What is the value you want to keep it? So I say that it's 0 0.5, and here you can provide a unit, and you can assign what is the minimum and maximum value. And if you want to give some description, you can give it. That's up to you. So now instead of a constant, now we have created a tuning parameter. So like I said, this tuning parameter is created inside our data dictionary, right? So you can go to your Explorer and you can open SLDD and inside the external data, you can verify that, yeah, this parameter is created here. And you can see the value as a 0.5 and the range and the unit, etc. here. If you want to edit it, you can also edit it here. That's up to you. So now we have a signal and we have a parameter. So let's compare the signal against the parameter. For that one, I want to use the block less than or equal. So the first input give, I connect to the signal, and the second input I connect it to the parameter. Okay. Now it will provide an output whether the vehicle is in standstill or not. So it depends on the vehicle speed and the threshold. So if the vehicle speed is below the threshold, then we get the output as a true. That means the vehicle is in standstill situation. So that's our first requirement. And let's go to this requirement. And the second requirement is brake is released. So that means this signal should be false, right? So you can do two things here. Either you can use equal operator to check whether this is a false or not. So false is again another constant. Here you can say false, and you can compare like this. So this is one of the way to check whether the brake is released or not. So the other way is like you can simply insert a logical operator not. Yes. So this will provide an inverted output. So this is another way. And let's go to the requirement. Check the third requirement. So the third requirement says the gear should be D gear and the slope is upward slope. Let's take the gear first. Now the gear is an enumerated one. So if you want to check against another enumeration value, then you have to use enumerated constant. Okay, and double click. Here you select your enumerated type and here enumerated value. So now we want to check whether the gear is D gear. Okay, so again use equal operator. Yes. So now we check the gear, but we also need to check whether the slope is upward slope. So upward slope means we can consider it as a positive slope. So we can check against 0. If it is greater than 0, then we can consider it as a positive slope. So for that one, I use a greater than operator and I create a constant and assign the value 0. So now the first condition check whether gear is in D gear, and the second one checks whether the slope is upward slope. Now both the conditions should satisfy, right? So we have to use AND operator, right? So for that one, we will select logical operator, and in the logical operator, the default one is and if you click it, you will have many options like OR operator, NAND, NOR, XOR, and the NOT operators. Okay, okay. So yeah, it provide an output whether if both conditions are satisfied. But we also have to check uh, the other part of it. For example, the gear is R gear, the downward slope, right? So for that one, we have to use the same signal again. Either you can do like you can create a equal operator and connect this signal to this. This is also okay, and create another enumerator data. Okay, now we want to check the slope is downward slope, right? So we'll use a less than operator and check against the constant value 0. Okay, and then insert another logical operator. Okay, now as per our requirement, if any of these two conditions satisfied, then we have to set this trigger, right? So for that one, we use logical operator OR, connect these two signal to OR operator. Yes, like this. So now this requirement is finished, right? So let's go to the next one. Next one says the slope is within the limit. That means the hillward control cannot support if the slope is more than certain threshold. For example, if the slope is more than 30 degree or 30 percentage, then it cannot support because it cannot hold the pressure, uh, too much pressure for a longer time. So that's the limitation of the hillward control. So again, we have to use the slope signal and let's create a tunable parameter. So for that one, create a constant and assign a name like this, slope threshold, and go to this triple dot and say create. Now we can create the parameter inside the data dictionary. And for example, you want to support until 25% of slope. The slope can be provided in a degree or in terms of percentage. So here I use a percentage. So now we have created a threshold. Then we can check the slope against the threshold. So it should be less than or equal to our parameter. Then we can activate hill control. And the final requirement, the disable signal should not be set. So for this one, I will use logical operator not. Okay. Now let's come to the last point. So in order to set this trigger, so all of these conditions should be satisfied, right? So we will use AND operator, but here we have only two inputs, right? But we have to check all of these. So one, two, three, four, five inputs we need to check it. So for that one, we can increase the input of this AND operator by right click or double click. Here, change number of input ports to 5. Okay, so now we can connect all of these signals to AND operator. Okay, now we can connect output of this AND operator to this output signal. So now we have completed the design or the coding for this module. Okay, so this is the pictorial way of doing this. Okay, let's also see how to do the same thing using a C kind of language. Okay, if you want to write a coding, then you go to the modeling tab, and here you insert chart. You click on this. Yes, now the chart is created. Here we will learn another thing, like these signals are already used here, right? So we can use the same signal by doing like this. So this is the one way, but it's not so clear because it is, it's going through uh, the lines are crossing each other, so it's not so clear which line is connected to which port. So in order to avoid this, we can duplicate this port. So there is an option available. If you want to duplicate this port, then you press the control key and hold the control key and then drag this input. Then leave your control and mouse cursor, then say duplicate. Now it will duplicate the same port. Okay, so by doing this way, we can connect the same signal to our state chart. Okay, the similar way, we will duplicate all other ports. Okay, now we have duplicated all the signals. We will connect to state flow diagram, and the next thing is give a name. If you haven't duplicated, then the name is automatically created inside the state flow. Since we duplicated the ports, it's not automatically created, so we will have to provide the name manually. Okay, let's go inside the state flow diagram, double click and open it. Yes, this will open yellow background page. So here we can write the coding. So how to write the coding? So this is like a flow chart. The flow chart always start with a default transition, and then it branch out. It depends on the condition, and then it will have a one exit right. So similar way, we will always start with the default transition. Okay, so this is our default transition, and then okay, let's implement our first condition. So our first condition, you remember that we have to check whether the vehicle is in standstill or not, right? So click from this junction and create another junction. Okay, so here it will pop up two things. So we have to provide a condition inside the square bracket, and then the action inside the curly brackets. So what's our condition? Vehicle speed less than the threshold, right? So vehicle, okay, let's go back, copy the name. Let's check against our calibration parameter. Okay, okay. So this transition checks whether the vehicle speed is less than this threshold. So if it is less than threshold, what we have to do? So we can create a temporary variable like vehicle stand still equal to true. Okay. Then every action statement should end with a semicolon. You have to remember it. Similar to the C language. So this is the if part. Okay, if the vehicle speed is less than the threshold, then the standstill is true, right? But there should be an else part where we have to say that the vehicle standstill is false, right? So the else part, for creating else part, click from this junction and move it downwards and select the junction here. Here you don't need to check the vehicle speed greater than threshold because by default this will be considered as a else part. Okay, here we can assign vehicle speed equal to false. Okay, so this is a if part and this is an else part. So now we can join these two things together like this. This is the one way, or you can create like this. Create one junction here and then come to this junction. So this is another way. So now we have checked the vehicle speed is in standstill or not, right? In a similar way, we have to check whether the brake is applied or released. For doing that one, I created one empty transition and the next transition I do it here. Say brake applied. Yes, we don't need. Yeah, you can do like this. Create an S part and assign our local variable false. So this will satisfy our second condition. And in our third condition, we have to check the gear. So we need to check two things, right? One is the gear and the other one is the slope. So here we'll check the gear first. The gear is a P gear. So we cannot write it uh, the enumerated value like this. If you want to compare the enumerator signal against the enumerator constant, and first we have to provide the data type over here. Let's copy the name of the data type. So gear type underscore en is our data type. And then put a dot and then give a member name, which member you want to compare. So we want to compare against to member D, right? So here you can input D. So yeah, by doing this way, we can compare the enumerated signal against to the enumerated constant. So as per our requirement, so this should be D gear and slope should be upward slope. And we have two conditions, right? So we can write it in the same line, or the gear is or gear and the slope is negative slope. Yeah, in a single line, yeah, we can check all the conditions together. So if all the conditions are satisfied, then we can set one local variable as a here, okay, equal to true. If these conditions are not satisfied, then we can say here, okay, is false. Yeah, now we have checked the vehicle standstill, brake release condition, and also the gear and slope, right? Now we have to check whether the slope is within the limit or not. So for doing that one, le- let's create another branch and check the slope against our threshold. Let's copy the name of the threshold from the DD. If slope is less than threshold, then we can say slope is okay. Otherwise, we can say slope is false. Here we have to note down one thing that the slope could be either positive or negative. So if you want to check uh, both the thing, then either you can do like you can check the positive slope like this, and the negative slope is like so. You can check the negative slope also like this. Okay, we have to change the name because slope name already exists. So it will give an error. So now the positive slope and negative slope is within the limit. So that we have checked now. So this is the one way of doing it. So the other way is like we can take a absolute value of a slope and then check against the threshold. So if you want to take absolute value, then you can type ABS and put the signal inside. So this will give you the absolute value. So you don't need to check this part. Okay. But I think now we go back to the pictorial way. Here we didn't do it. So in the pictorial way, how to do this absolute value check. For that one, you type ABS and then insert the ABS in between the signal and with less than equal to operator. So now we can take absolute value of the slope and then check against the threshold. So this way we can do it in a pictorial way. And then the last check is our disable condition. This should be false. If it's false, then we can say okay to true. Otherwise, we can say false. Now we have to check all of these conditions are satisfied, like we did it using a logical operator and, right? How to do that? So we can check our first condition. Equal standstill should be true. And the next condition is break not applied is true. Third condition here, okay, is true. And then the next condition, slope, okay, equal to true. And the next condition, true. Okay. All of these conditions are satisfied, then we can set our trigger condition to true. If any of this condition not satisfied, then we can say trigger equal to false. And then we can have a one default exit condition like this. So this is the one way of doing it. Our job in the state flow is not finished yet. Uh, we have to click this symbol span. So here we can see that what are the variables we used inside our state flow is listed over here. So this symbol indicates these are the input data. But here one of the input data it shows that it is unused. Yes, because we have used the wrong name here. We have a typo here. Okay, yeah. And we have a lot of temporary variables. So, and these are the internal to this module. So we have to inform the state flow that these are local variables. For example, you click on this icon and set it as the local data. And similarly, this is also local data. This one, Yeah, and yeah, the trigger is our output data. We have two triggers because the first letter is a small letter here and here is a capital letter. So that's why we see two triggers. Let's rename this one. Yes. So this is output data. So the state flow also propose this as output data. Yes, it is an output data. So set it to output and yes, I have to change this one to small case. And we have two variables here. Actually, these two are parameters, right? So we have to tell state flow that this is parameter data. Yes. Now there is no error in the symbol span, but we haven't provided any data type to our output signal and also for the local data. We didn't provide any data type. So you click this property inspector and select vehicle standstill. Or you can do right click on standstill, say inspect. So the scope is the local, yes, okay. But this is a Boolean type. So select Boolean. And also for the slope, it's a Boolean and this again a Boolean signal. Here, okay, is also Boolean signal. And this one also Boolean signal. And the output, so the output also a Boolean signal. Yes, now we have done everything. And now we can check whether this state flow is okay or not by compiling. So click this one, update model to compile. It's found there are some problems. Yes, this is the input signal, so we can't override the input signal. That's my mistake. Let's compile again. Okay, there is an issue with the unit because there is some unit is missing, so we can disable the warning. Yes, now there is no error. So this is the way of writing software code. So this is one way of doing it. So we can also optimize the same code. Like we don't need to explicitly check through. So this is another way of simplifying this. Uh, so we can use a number of methods. It depends on the programmer. For example, we can write only one if condition and check everything. That's also okay. Or we can do it in step by step, like what we did. So this is also okay. For example, I want to do all the checks in one if condition. Okay. So how to do this? Yeah, let's try. Like the wheel speed is less than threshold, and the brake applied as false, and the gear check, and the slope check, and finally the disable signal check. All of these conditions are satisfied, then we can say trigger is true, or otherwise we can set trigger equal to false. Yeah, so we can do this way as well instead of doing it in multiple if conditions. We can do it in a one single if conditions. So it's up to the programmer. But here I want to teach you one more thing. Here, if you see this line is, too big, if you want to write it in multiple lines, then if you press enter here, it will throw an error. But still, if you want to write in multiple lines, then type three dots over here. Then you can write it in multiple lines. For example, like this. Yes, yes, like this. You can write the code in the multiple lines. Okay, I hope you have understood. Let's go back to the pictorial diagram. So here is a general rule how to use whether the pictorial method or the program method. Uh, we always suggest to use the pictorial method as much as possible. If you are unable to do it, then you can switch over to programming method using a state flow diagram. So this is my suggestion. So let's keep the pictorial method. So similar way, we can also do it for other modules. So this is the end of today's class. In the today's class, we have seen how to write a program in a graphical way, and also like a C program using a state chart. Okay. So in the next class, we will see also about the other modules, and also how to do the state machine.